For exercise 506, I have done a few worked solutions, and I'm just going to very quickly talk through these and put the still shots up. So in question 13, they had this one. Now, basically, anytime that you've got a fraction, you're going to find it's got some sort of hyperbolic type shape to it. Maybe not for the whole curve, but certainly at the ends. I have rewritten this in index form to find the derivatives. So we need to find the first and second derivative. I've done them there, you can read through those. So stationary points are when the first derivative is 0. There were no stationary points. 2 over 1 minus x all squared equals 0 when the numerator equals 0, and the numerator never equals 0, so there are no stationary points. Same thing, no points of inflection. Now that's quite important that there are no stationary points and no points of inflection. So that tells us the concavity never changes anywhere on the smooth part of the curve. No stationary points, so no minimums, no maximums. Okay, intercepts, when x equals 0, I did get one at 2. I might just mark that on the curve now. So that's the point right there. Now, for the asymptotes, the vertical asymptotes are when the denominator equals 0, so that's at x equals 1. Now, I've already drawn that on at x equals 1. For a horizontal asymptote, we want to look what happens as x goes to infinity. Now that equals 0. Basically, just keep putting in bigger and bigger numbers. If you put in 10 into this, well, into this actually, you get negative 105. You put in 100, you get negative 0.02. This is negative 0.2, negative 0.2, 0.02, and negative 0.02. So you can see the number of zeros there is increasing. It's going to get smaller and smaller and smaller and smaller, so it approaches 0. Okay, so let's draw that. Now, the cool thing about asymptotes is a curve will always tend towards an asymptote. This is a very basic hyperbolic shaped function. It is a hyperbola. It's just, if you think about our transformations, the x is multiplied by 1, and then there's like 1 added onto the x. Okay, so that is not in our standard form. If I was to write it in our standard form, I would go 2 over negative x plus 1. So 2, I must factorize x minus 1. So it's a shift 1 to the right, and it's negative. So it is reflected through the y-axis. Now, the thing about hyperbolas is they're always squeezed between asymptotes. They're not going to cross these asymptotes. They never, ever cross a vertical asymptote. It is possible for a function to cross a horizontal asymptote, but only around the middle, never at the ends. So what's going to happen is it's going to come up to the asymptote, and it's going to go down to that asymptote. It's going to be squeezed between the asymptotes. And this function has a lot of symmetry to it. So this point here, from here, I go 1 across 2 up. If I go 1 across 2 down, there'll be a point there as well. And that'll go down to the asymptote because it can't go up because it won't cross here, and up to that asymptote.